Now let us discuss the volume and surface areas of solids of revolution. The first case is if the axis of revolution is the x-axis. That means if the given curve, for example, suppose this one is a given curve represented by y is equal to f of x. Between x is equal to a and x is equal to b, because between x is equal to a and x is equal to b, it will be a closed curve. So if between these 2 points x is equal to a and x is equal to b, y is equal to fx revolves about the x-axis, then in that case it will generate a solid. So for example, suppose this one is the x-axis and this is that given curve. So when it revolves about the x-axis in this way, then it will generate a solid, and it will this solid will have a volume and a surface area. So therefore in this case we need to find out what will be the volume and surface areas of solids of revolution revolving by the given curve about the x-axis or the y-axis or another line which may be parallel to the x-axis or the y-axis. So the first case is this one. So if a curve y is equal to fx revolves about the x-axis to form a solids of revolution between x is equal to a and x is equal to b, then the formula for the volume will be given by pi is equal to integral a to b y square dx. So this will be the formula to evaluate the volume generated by revolving the given curve with respect given curve with the x-axis between x is equal to a and x is equal to b. And the surface area is given by the formula twice pi integral a to b y into square root of 1 plus dy dx the whole square dx. So for the surface area it will be this formula. Now case 2, if the axis of revolution is the y-axis, that means suppose this is the y-axis and the curve revolves about the y-axis, then in that case the volume of solid of revolution will be given by the formula pi integral a to b x square dy, where between y is equal to a to y is equal to b in this case. These are the limit of integration with respect to y. And the surface area is given by the formula integral a to b x into, now here it is x into square root of 1 plus, now dx dy the whole square dy. So this will be the formula when the axis of revolution is the y-axis. Now if the axis of revolution is the line y is equal to h, it will be, suppose this is the x-axis, xy axis. This is the y-axis. Y is equal to h may be somewhere here. So y is equal to h. So it will be a straight line parallel to the x-axis. So in this case, if the axis of revolution is neither the y-axis nor the x-axis, but it is a line which is parallel to the x-axis given by y is equal to h, then in this case, the volume V will be given by the formula pi integral a to b y minus h the whole square dx. And the surface area is given by the formula twice pi integral a to b y minus h into square root of 1 plus dy dx the whole square dx. And the last one is if the axis of revolution is the line x is equal to h. Now this is the y-axis, this is the x-axis. X is equal to h, suppose h is here on the x-axis. So draw a line which passes through x is equal to h. It is a line parallel to the y-axis. So in this case, if the axis of revolution is this one, that means the curve revolves about this x-axis, then in that case the volume V is given by the formula pi integral a to b x minus h the whole square dy, and the surface area is given by twice pi integral a to b x minus h into square root of 1 plus dx dy the whole square dy. So we'll apply these 4 formulas in solving the problems, depending on which axis is the axis of revolution. So let us come to this first problem. The path of the parabola y square is equal to 4ax cut off by the latus rectum revolves about the tangent at the vertex. Find the volume of the solid generated. So we have here in this case we have to find only the volume generated by revolving about the tangent at the vertex. Now here see this one. Y square is equal to 4ax represent a parabola. So you draw this curve of the parabola and the y-axis or xy axis, and then we know that the vertex of this parabola y square is called 4x is the origin, that is 0 0, and this is a line which touch the y-axis touch the vertex at point A, so it will be a tangent at A, and on the y-axis we know that x is equal to 0. So now here cut off by the latus rectum. For a parabola y square is equal to 4ax, the coordinate of this focus is A0, as we have discussed in the second semester all this thing in detail. So we know that the focus of the parabola is this one, A0. Now the latus rectum is nothing but it is a straight line which passes through the focus and also perpendicular to the x-axis. So L prime will be the latus rectum. So if the coordinate of this point S here is A0, that means x is equal to A, then what will be the coordinate of L and L prime? So you just substitute A. We have y square is equal to 4ax. So y square is equal to 4a at x is equal to a. So it will implies that y square is equal to 4a square, and this implies that y is equal to plus or minus 2a. So plus 2a will be the coordinate of y at point L, and then minus 2a will be this one which lies below the x-axis. So now here, according to this question, we need to find out the volume generated by revolving this part which is bounded by this one, the latus rectum and this line above the y-axis. So above the y-axis, so this portion here will rotate above the y-axis, and it will generate a solid, and the volume of that one will be given by the second formula. That is, if the axis of revolution is the y-axis, then v is equal to pi integral a to b x square dy. And here what will be the y is equal to x square dy. But from this given equation, y square is equal to 4ax. What we have now is that we can find out what is x square. X square is equal to, you calculate first x is equal to y square by 4a. So x square is equal to y square by 4a the whole square. So replace the value of x square by this one, then you get pi integral. Now here it is from 0 to a, because at this vertex here, or this line or the tangent, x is equal to 0, and at this point x is equal to a. So it will be from 0 to a, not from 0 to a, because we need to find the coordinate of y. It is from minus 2a to a. And then x square has to be replaced by this one, y square by 4a the whole square dx. So this can be calculated easily because it is just a simple integral. So how to find out the volume generated by revolving this parabola cut off by the latus rectum about the x-axis? So first step what you need to do is find the coordinate of this, the y coordinate of this L prime and L, so that you will be able to know the limit of integration. For y, it will be from minus 2a to a, and then use the formula v is equal to pi integral a to b x square dy. And then substitute this one x square from the given equation of the curve. You can find out what is x square and substitute it here and evaluate it. So then you will get the volume. Hope it is clear now with this problem.